Okay, so this is your first flip lesson, so you want to make sure that you turn in your notes packet to lesson 2. And we're not going to be going through every single problem in the lesson. I'm just going to highlight a couple things. So right now what I'd like you to do is I want you to try my do now, and I want you to pause the video, and you should be trying it on your own. Okay, so at this point you've tried it, and for the first part, you should have been okay with getting 12x. 5x and 7x are like terms, so I combine their coefficients and I get 12x. Now, radicals work in a very similar way. In fact, you could think of the radical 3 just like the x. So I have 5 radical 3's plus 7 radical 3's. Altogether, I have 12 radical 3's. So I figured out how to combine my like radicals by taking their coefficients and adding them together. So if we have like radicals, we can add or subtract them by combining their coefficients. Okay, so that's what this lesson is going to focus on. Now, for number 1, this didn't start as like radicals. Sometimes you have to simplify the radicals in order to figure out if they're like radicals or not. So here I broke the 12 down into 4 and 3, and the 27 down into 9 and 3. This reduces down to 2 radical 3 plus 3 radical 3. So now here, these are like radicals. So I'm going to add their coefficients, and it's going to become 5 radical 3. Now for number 2, this is the same idea, but instead of being a square root, it's a cubed root. So you just need to make sure you're taking the cube root instead. So the cube root of 8 is 2, but my x is going to stay inside because x is not a perfect cube. Remember, for a variable to be a perfect cube, his exponent needs to be divisible by 3. Again, 27 is a perfect cube, so it can come out of the radical. So now here, these are like radicals, so I can combine their coefficients, and I get 5 times the cube root of cube root of x. So that's that question. So what I'd like you guys to do next is I want you to try number 3 and number 5. So I'm going to have you pause the video, and at this point you should be trying them. Point you should have tried 3 and 5. So for number 3, you're going to break down your 20 into a 4 and a 5, and I'm going to leave x to the 4th under the radical on its own. Anything that's a perfect square, you're going to simplify. So the square root of 4 is 2. The square root of x to the 4th is x squared. 5 is going to stay under. Same idea here. I'm going to break down the x to the 4th out of the 5. So the square root of x to the 4th is x squared. Anything that came outside of the radical is going to get multiplied with the coefficient. So here this becomes negative 16x squared radical 5. And then here this becomes negative 8x squared radical 5. So now I'm going to combine these coefficients because these are like radicals. And I'm going to have negative 24x squared times radical 5. And that's my final answer. Number 5 works in a very similar fashion. I break down the 90 into 9 and 10. The 10 for this radical stays on its own. The 40 breaks down into 4 and 10. Similarly, when you look at x to the 7th, remember, to be a perfect square variable, you need to have an exponent that's divisible by 2 or something even. So we break the x to the 7th down as x to the 6th times x to the 1st. X to the 6th is a perfect square. When I take the square root of it, the exponent gets cut in half. It becomes x cubed. So same idea here from that x to the 7th. This x stays on its own. Okay, now we're going to work through the rest. So the 9, square root of 9 became 3. I have my x cubed. And same idea as you follow through. And then what ends up being nice here is that everybody has the same number under the radical. The fancy name for that is a radicand. So I'm going to combine all their coefficients. So 3 plus 5 minus 2, and that's going to leave me with 6x cubed. Okay, at this point, you should be good. As your homework, I'd like you to